Now, in our discussion of the F ratio, this is going to correspond to section 8.2 of your textbook. I am going to show you some formulas as well as show you how to work with the formulas, but the book includes very detailed and very helpful step-by-step procedures for solving for the F ratio. So just to continue on with the last lecture, the F ratio is a ratio of between group variance and within groups variance. And the larger this ratio, or the greater difference between groups and within groups variability, the more likely we are to reject the null hypothesis. Remember, in our last illustration, we discussed the within groups variability as a deviation of raw scores from a group mean, and between groups variance as a deviation of group means from the grand mean or the total mean. Now, the pieces of the variability pie are discussed in section 8.2, and you can use whichever formulas you prefer to use. The book does a pretty good job of working through the definitional formula. So let me just take you through what these mean, because if this is your first time seeing these terms, it's likely to be a little confusing. This is the uppercase sigma, and this literally means to add up. Okay? This refers to our observation of x. This is our grand mean or our total mean. Okay? And these refer to the idea of group means. So as we can see, we have a total sums of squares, which refer to the squared deviations of every single x value from the grand mean. And then we have our within groups variance to refer to the fact that we're now dealing with individual values of x from only within a certain group. So I'm going to have 3 indications of within group variability in a 3-group case, 1 for each group. And then I have my between groups variability estimate, which refers to the extent to which our group means vary from this overall mean. Now, the calculation of variance, the sums of squares, is really heavily influenced by sample size. And so to overcome this, we calculate what's known as a mean square in analysis of variance terminology. And we do this between and within groups. So I can solve for the mean square between, for example, by taking my sums of squares between and dividing by degrees of freedom between, when the degrees of freedom is defined by k minus 1, when k is the number of groups. So if I have 3 groups in my study, then 3 minus 1 is 2. My denominator here is going to be 2. If I have 5 groups, my denominator is going to be 4, etc. And then my mean square within, I take the sums of squares within and I divide by the degrees of freedom within, when my degrees of freedom within is the total number of observations in my group minus my number of groups. And so in the case where I have 20 people in a sample, okay, and I have 3 groups, it's not as easy as it looks writing on here, then my degrees of freedom for within would be 20 minus 3, or 17. And then the end game in all of these calculations is so that we can arrive at our F ratio. Remember, I described the F ratio as a ratio of between to within groups variance. And so we can see mean square is an estimate of variance that controls for sample size. So to the extent that I have a large degree of between groups variance relative to a small degree of within groups variance, I'm likely to have a pretty large F ratio. Now, I took this image from another textbook that I've been using for a while, because your textbook didn't have a good discussion of the analysis of variance source table. But all of these things that we've been talking about go into what's called a source table in analysis of variance. And it has 2 essential lines. Okay? It has the between groups variability, it has the within groups variability, and then there's also a component of total variability. So we talked about between group sums of squares being the sum of the group means subtracted from the grand mean. We talked about the within groups variability being the sum of the square deviations of the individual x values from their respective group means. And then we also talked about the total sums of squares, which was the total of all x values subtracted from the grand mean squared. Okay, so once we have those three, they go there. Okay. Then we have the n of groups minus 1, defining our degrees of freedom between groups, and then all of our degrees of freedom within groups being confined there. And then here I have, in a nice package, all of the remaining pieces. And so I put this in here just so you could see what an analysis of variance source table looked like and how the numbers in that table generate the F ratio. And so here's an example. I'm going to go ahead and just ask you to disregard this component here and this component. Okay? This is useful information, but it's meaningless for us right now. What I want to draw your attention to is the difference in the size of the F ratio. All else being equal, this one is likely to be statistically significant, whereas this one is likely to be not, because here I have an F ratio of 48, and here I have an F ratio of 3.2. What I want to draw your attention to here is this column here. Okay? Remember, we discussed the F ratio as an index of between groups to within groups variability. Here I have a huge difference between my groups relative to a relatively small difference between or within my groups. Here I have the same mean difference. Okay? This is the same degree of between groups variability relative to a massive amount of internal variation or variance within groups. For this reason, okay, the exact same mean difference, okay, the same amount of between groups variability is going to be significant in this case, but not in this case because of the extent to which this within groups variance estimate is really small. So always remember that the F ratio is a ratio of between to within groups variability. We might have a huge amount of variability between our groups. Here we have the exact same amount, 96 versus 96. So it's not necessarily the between groups variability that drives the significance test. It's actually the extent to which the between groups variance is large relative to a small within groups estimate.